Hello everybody, today I'm going to explain the first problem from the 2025 US Open Contest in the Silver Division, the problem sequence construction. In this problem, we are given several test cases, and for each of the test cases, we must construct a sequence of length n in such a way that the sum of the numbers is m and the bitwise XOR of the pop counts equals k. And we want to find whether a sequence exists, and if it doesn't, then we print -1. Now, as it's customary for constructive algorithms and for constructive problems, we actually want to construct a solution which is as optimal as possible because there can be a lot of constructions which work, but we want to be careful at the way we want to obtain these sums. And I would say that given these three conditions from the statement, I would say that the third condition deserves the most attention. And now, in order to obtain a sequence of pop counts such that the bitwise XOR equals k, then it's worth looking at the binary representation of k, because we are allowed to use up to 100 numbers. So we don't have that much of a restriction as far as this goes. So now we want to make things in such a way that the bitwise sort of the pop counts equals k. We will then come back later to the condition on the sum. So now, in order to obtain a sequence with the pop count, the sort of the pop counts equal k. So let's say that if k equals 22, we know that 22 in binary is something like this. So 16, 8, 4, 2, 1. So basically 22 equals to 16 plus 4 plus 2. So in order to have a sequence with the sort of the pop counts equal 22, we want to have a number with 16 bits, a number with 4 bits, and a number with 2 bits that are set. And now, because we also have to be careful about the sum of the values we obtain, a way to construct these numbers such that they are as small as possible while also having this amount of bits is to rely on numbers of the type 2 at x minus 1. So for 16, that would be basically 2 to the 16 minus 1, 2 to the 4 minus 1, and 2 to the power of 2 minus 1. Because in binary, they will be of this type. So they will have a lot of ones. And basically, when it comes to the pop count, it doesn't matter how are the bits placed. But we want a simple construction, also something that gives us a small value. And now, using this, because k is up to 31, we will have at most 5 numbers in our constructions. So from this point on, we shouldn't even care about this condition, because no matter what we do, we won't ever be anywhere close to 100. So it's better to just not pay attention to this and focus on the remaining condition. We also established this condition by having the pop counts. So now all we care about is making sure that we reach the sum equal to m. And now we have uh, two important things to consider. So because we have this sequence of numbers, powers of 2 minus 1, then we actually care a lot about whether this sum of values is greater than m or not. Because if this sum of values is greater than m, then there is no solution. There is no way we can actually achieve a lower sum, and we would be basically screwed, so we would have to print -1. But if this sum is smaller or equal than m, then we still might have to be careful about two things, because we want to actually construct that sequence with the optimal property. So if the parity, or so if the sum isn't equal to m, we need to add numbers which sum up to m minus whatever the current sum is, but the XOR of the pop counts equals 0. So we want to have maybe two numbers that have the same amount of bits, so such that they cancel each other out. And because of that reason, because we want the numbers to have the same amount of bits, we might just as well use maybe powers of 2 or something very simple to construct, or maybe the difference divided by 2. And based on this, we actually have two cases. So let me note the sum of the current value with S. And if S and M have the same parity, so let's say M minus S mod 2 equals 0, then basically we can just have two more numbers appended to the sequence, M minus S over 2, and we add it again. And the reason why this works is because these two numbers are equal. If we add them to whatever we had, the sum will be M. And because the numbers are equal, their pop counts will cancel each other out. So they will not affect our XOR. Now, what if the difference is odd? This is a trickier case because we can't do this anymore, since we have to also be careful about the way we want to construct our difference. So now a way to think about this is all of these numbers we added are odd. So if we double one of them, then they will become even. Then the number itself will become even and it will change the parity of the sum. But this might not be enough, because imagine if you have a really big number, you double it, and then your sum goes over M. So this is not really the best option. But there is actually a really cool way to add two more numbers to this sequence in such a way that the parity is changed, but the XOR is not affected, the XOR of the pop counts. And this method actually is to add a 1 and a 2. Both of them have a single bit, and we increase the sum by only 3. And 3 is a very small odd number, so this will definitely improve our answer. Now, in order to actually see whether this works, we might also have another case, because imagine if we have already a single 1 or even a single 3, but let's say a single 1 in the construction. Let's say that k is odd. If k is odd, then we have a 1 already, and we can just turn it into a 3, or even into a 2. Actually, we can just double it. And this difference would be 1, but this difference would be 3. So because both of them are odd, it's always better to go for the 1 if we have the chance to reach it. And in order to conclude, if we get this and we can still obtain a sum that is smaller or equal than M, we can come back to the case when the parity is the same. So same parity. And with that being said, this problem is a problem where we had to realize that we want to first start with constructing small numbers in order to have as good of a margin as possible to keep going with other numbers, and then be careful at one or two corner cases that if they are not treated, then most of the test cases will be wrong. So as I show here in the code, I start by computing the uh, numbers that will be part of the initial sequence. Obviously, if the sum is greater than M, there is no point in continuing. If the parity is the same, I just add the same thing twice and it will work out. And now I have this case where I basically check whether the first number is smaller than 3, because basically it means that it's 1. So we can just double it and have the smallest increase in sum. And here, otherwise, I just add the 1 and the 2. The sum goes up by 3. And here I come back to the cases I wrote earlier in the code. I now know that the parity is the same, so I just have to add these two cases. And now at the end, I just print the sequence of powers, and then I am done with the problem. Again, the code is very short. It's one of these problems on which the difficulty of finding the idea is way higher than the difficulty of coding it. So in order to solve these problems, you have to be really careful at ways to think at these problems, to simplify things. And in a way, this problem felt a lot like these problems you maybe see on code forces, these sort of div to b's, div to c's. You see where you have to construct a certain array with some properties. So again, having the experience and the background of problem solving from across the online judge is something I do with my students as I help them progress, is something very useful and very important. If you enjoyed watching this video, please like the video, subscribe to the channel, and press the bell button in order to stay notified with everything I do on the channel, especially now as the season came to an end. And I'm planning to fill this off-season period with a lot of useful contents, be it with educational materials, more USACO problem solutions, as well as other interesting stuff, maybe even covering some live contests, depending on how much time I have. Also, if you or someone you know is interested in working more closely with me and being trained by a top trainer, by a top tutor, please check out the links in the description for ways to join my tutoring program, as you can be one of the next students to achieve USACO success, just like 20 students did during this season as they got promotions to higher divisions. Until the next time, good luck with your summer practice, and I'll see you in the next video. Cheers!